Good morning, girls. Today I'm going to take a class on plane touching a sphere. Can you see the document, girls?
Yes, ma'am.
Yes. Yes, please listen to the class carefully, girls. All these problems we have worked out in the class and also revised. Luckily, we have one more choice, like one more chance to revise all these problems. So today we will see actually what exactly plane touching a sphere means. You have seen plane intersecting a sphere, which will give you a circle, and you are able to do the problems on finding out that circle's center and radius. When a plane intersects a sphere, you get a circle. Now here plane, you see the figure, plane is touching a sphere. This is how only we can draw the figure. You imagine on a plank there is a ball like that. Just imagine that a ball is placed on a plank, that you can draw like this as shown in the figure. Okay, here the sphere is this and it is touching a plane at only one point P. Okay, so what is the condition, girls? See, if you see this figure, this is CP. CP is where C is the center of the sphere, and actually the sphere touches the plane at only one point P. If you see this CP, this is not only the radius of the sphere, it is the distance of the plane from the center of the sphere. And if a plane touches a sphere, then the distance of the plane from the center of the sphere is exactly equal to the radius of the sphere. Okay, that is what I mentioned. See, here you have a sphere. The equation of the sphere is this: x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. And this sphere, if at all it touches a plane, what is the equation of the plane? Ax plus by plus cz plus d is equal to 0. Then here if you see the figure, the radius of the sphere is, that is Cp, is exactly equal to the distance of this plane from the center of the sphere. Okay, so this is the formula: distance of the plane from the center of the sphere. What is the center of the sphere? Minus u minus v minus w. So here plane is a, x plus b y plus c z plus d is equal to 0. The distance of the plane from a point, the formula is a x1 plus b y1 plus c z1 plus d by square root of a square plus b square plus c square. That is what I put. This is what? This is the distance of the plane from the center of the sphere. And here radius of the sphere, you know, u square, square root of u square plus v square plus w square minus d. When the distance of the plane from the center of the sphere is equal to the radius of the sphere, we say that the plane is touching the sphere. Okay, now this condition you must remember, girls. And distance being positive, it should be in modulus, absolute value you should take. So let me do two problems on this model. The very first question is this: show that the plane 2x minus 2y plus z plus 12 is equal to 0 touches this sphere, and also find the point of contact. Just now I discussed, no? See, when a sphere touches a plane, or when a plane touches a sphere, there will be only one point of contact. Okay, in this problem he asked you first to show that a sphere, given sphere, is touching a plane, and also is asking us, if that is the case, what is the point of contact. Okay, you are asked to find out even p also. So what you have to check is, you have to find out the distance of the plane from the center of the sphere. That is the first step. And you have to find out the radius of the sphere. This is the second step. And you see whether both are equal. When both are equal, you can say that the sphere touches the plane, or the plane touches the sphere. So I took the equation of the sphere as S is equal to 0. This is the given sphere, girls. And we are going to find out its center. First we need its center, no? So to find out the center, what you have to do? You compare this given sphere to the standard general equation of the sphere. Okay, this is the general equation of the sphere, girls. When you're comparing the equation with the general equation of the sphere, here coefficient of x is 2u. 2u is equal to minus 2. so that u is equal to minus 1. Now you compare the coefficients of y. Y coefficient here is 2v, y coefficient here is minus 4. So 2v is equal to minus 4, from which you get v is equal to minus 2. And now compare the coefficients of z. Here the coefficient of z is 2w. Here coefficient of z is 2. So 2w is equal to 2. W is equal to 1. And of course we have the constant term d is equal to minus 3. So now we are going to find out to see the center of this given sphere. So what is the center of the sphere? Minus u, minus v, minus w. So minus u means it is 1, minus v means 2, minus w means minus 1. After getting the center, you have to find out the radius of the sphere using this formula square root of u square plus v square plus w square minus d. U is minus 1, so u square minus 1 square, v is minus 2 whole square, w is 1, 1 square, minus d. Here d is minus 3, minus d is plus 3, so that you get the radius of the sphere as 3. In the figure, radius of the sphere is denoted by the line CP, so the distance CP is the radius of the sphere. That's what here. So now what I have to do is I have to first find out the distance of the plane from the center of the sphere. Okay, so to find out that what is the given plane is, this is the given plane. So you are going to find out the distance of this plane from the center of the sphere. Okay, so distance of the plane from the center of the sphere. See, center of the sphere, just now we found out 1, 2, minus 1. So here ax1 plus by1 plus ez1 plus d by this. So x1 here is 1, y1 here is 2, z1 here is minus 1, and a here is 2, b here is minus 2, c here is 1, and of course d here is 12. So I'm finding out now the distance of the plane from a point, and that point is center of the sphere. So distance of a plane from a point is this formula. Substitute and get the value 3. So now because you are going to check whether the plane touches the sphere. So to check whether the plane touches the sphere, you have to find out the radius of the sphere and you have to find out the distance of the plane from the center of the sphere. So radius of sphere is 3 and distance of the plane from the center of the sphere is 3. So because the distance of the plane from the center of the sphere is exactly equal to the radius of the sphere, you can conclude that the plane touches the sphere. So the first part of the question is, he asked you to show that the plane touches the sphere. We have proved that the given plane touches the sphere. How? By checking whether the distance of the plane from the center of the sphere is exactly equal to the radius of the sphere. The distance of the plane from the center is 3. The radius of the sphere is 3. Therefore, the plane touches the sphere. Now, he asked you to find out the point of contact, P. Okay. Now, if you see in the figure, what is P? It is the point of contact. But if you see this P, it is not only, it is actually lying on the plane. Okay. And moreover, this actually see this line CP is perpendicular to the plane pi. Okay. This CP is perpendicular to the plane pi. So now, you know, once you know the equation of the plane, you can say that this 2 is 2 minus 2, 1. They are the DRs of the normal to the plane pi. Okay, 2 comma minus 2 comma 1 are the DRs of the normal to the plane. Here CP is normal to the plane pi, so you are able to get the DRs of CP. Okay, CP being is perpendicular to pi and 2 minus 2 1 being the DRs of the normal to the plane, you are able to get now the DRs of the line as 2 minus 2 1. Let them be L, M, N. Now to find the equation of the line CP, you need a point through which it is passing and also its DRs. Already you know C, that point, and line CP is passing through C, and moreover you got the DRs of CP. So equation of the line CP I'm finding out. So the equation in the symmetric form, x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N. So here x1 by 1 z1 is the point through which it is passing. So C, that is the point C. It is 1, 2, minus 1. So x1 is 1, y1 is 2, z1 is minus 1. So x minus 1, here L is 2, y m is minus 2, n is 1. So from which equating each one, you will get x minus 1 as 2t, y minus 2 as minus 2t, z plus 1 as t, from which you get x value, y value, z value. So now you are able to get any point on the line CP, namely P. You are going to find out the point P, no? And what is this point P? This is a point on the line CP. So that's why I found out the equation of the line joining CP. And then I took any point on the plane line, means I got that point P as 2t plus 1 minus 2t plus 2, t minus 1. Now your aim is to find out P, no? Now see, P is not only a point on the line CP, girls. It is also a point on the plane pi. Why? Because it is the point of contact. Point of contact means it is lying on the line CP and also on the plane pi. So you have just now a point P, and being this a point on plane, it will satisfy the equation of the plane. So what is the plane here, girls? You have, it is 2x minus 2y plus z plus 12 is equal to 0. You put for x 2t plus 1, y minus 2t plus 2, z t minus 1. So that t you will get as minus 1. So you put this value t in the point P, you will get the point. Okay, this is what the very first question is, very important, a short answer question. He gave you actually a sphere and a plane, and he asked you to check whether this plane touches the sphere. That is the first step. We proved that the distance of the plane from the center is exactly equal to the radius of the sphere. So you confirm that the sphere is touching the plane, and if at all a plane touching a sphere, it would be having one point of contact. And he asked you to find out the point of contact, and you see the figure, P is the point of contact, means it is a point on the line CP and also on the plane pi. And once you have to find out the point P on the line, means you find out the equation of the line CP, girls, where CP is perpendicular to the plane pi. Okay, so to find the equation of the line, you need a point and its drs. Because CP is perpendicular to pi and pi's normals drs are known to you, they are the drs of the line CP. So equation of the line CP you can find by using the symmetric form, and you need a point on the plane pi line CP, means you take it as some t like this, you will get the point on the line CP. Okay, your aim is to find out the point P, which is the point of contact, and to get this point P, you have to find out T, and P is also lying on the plane pi, so it will satisfy the equation of the plane from which you get T value, and substitute this T value in the point P to get the required point of contact. So first question is very simple. We simply checked whether the given plane is touching the sphere, and then you found out the point of contact. Let us see the second question. Here we have find the equation of the sphere. You have to find out the equation of the sphere. How is this sphere? This sphere is passing through the circle. I told you, no, circle means it is the intersection of a sphere and a plane. A plane section of a sphere would be a circle. So he asked you to find out here, to find out that the sphere which passes through this circle. Circle means intersection of a sphere and a plane, and moreover, which is touching the plane. Okay. So here you are given a circle. Circle means S is equal to 0 is equal to pi, intersection of a sphere and a plane. Okay, where S is the sphere and plane is y ax plus by plus z plus d is equal to 0. This is the plane. Okay, now this sphere and plane are intersecting. You are getting a circle. So your aim is to find out a sphere which passes through this circle. Okay, so equation of the sphere passing through the circle, S is equal to 0 is equal to pi is, this is the formula which is very important. S plus lambda pi is equal to 0. You are going to find out this sphere only. To find out this sphere, you have to find out lambda. So to find the lambda, he gave you a condition that this sphere is not only passing through the circle, it is also touching the plane. Okay, so you have to use the condition of a plane touching a sphere. Okay, so your aim is now to find out this sphere, girls, which is passing through the circle, which is S plus lambda pi is equal to 0. I'm denoting it by S dash. Your aim is to find out S dash. S dash, to find S dash means you have to find out lambda. To find out lambda, he gave you a condition that this sphere is touching this plane. Okay, So now what you have to do for this first is you have to touching condition you have to use means you have to find out the center of the sphere and radius of the sphere. So first you compare this sphere with this standard equation. So here coefficients of x if you compare here 2u here minus 6. 2u is minus 6. Here 2v coefficient of y here it is lambda. 2v is lambda and when you compare the coefficients of z here is 2w here is minus 2. So you have your u is equal to minus 3, v is equal to lambda by 2, w is equal to minus 1 and of course the constant terms d here is 5. Okay, now you are finding out the center of this required sphere S dash. So center of the sphere S dash is minus u, minus v, minus w. Minus u means 3, minus v means minus lambda by 2, minus w means 1. And radius of the sphere is square root of u square plus v square plus w square minus d. So u here is minus 3 u square, v is lambda by 2 square, w is minus 1 square and minus d means minus 5. You will get this. And if you see the figure, see this is the sphere and this is the plane and the sphere is S dash. The required sphere is S dash now and the plane which it is touching is pi dash. So when you have here the sphere touching a plane, there is a point of contact. Now radius of the sphere you found out and that is denoted by Cp. So here Cp, radius of the sphere. Remember, given sphere is S, given plane is pi, S is equal to 0 is equal to pi is a circle, but you are finding out a sphere passing through this circle and we are denoting it by S dash. Now S dash is touching this plane. We denote it by pi dash. Okay. So to find out lambda, he gave you condition that S dash is touching this plane pi dash. So plane touching a sphere condition means you need to find out the radius of the sphere. So for this sphere S dash, I found out the center and radius. As per the figure, the radius is Cp. Now you have to find out the distance of this plane from the center of the sphere. So here pi dash is given to you. So I'm finding out the distance of the plane pi dash from the center. Distance of this plane pi dash from the center of this sphere S dash. So formula modulus of ax1 plus by1 plus cz1 plus d by root a square plus b square plus c square. And see here is I gave you already. See here is 3 minus lambda by 2, 1 and see here u means minus center. So I substituted the points here, a values and all these values you got this. So now this is the distance of the plane from the center of the sphere. But here he gave you that this sphere touches the plane. So once a sphere touches the plane, the distance of the plane is equal to the radius of the sphere. So distance you got as this much and radius you got as this much. So you equate them. Okay. In the previous problem, you were asked to show whether this plane touches the sphere. So you found out separately the radius. You found out the distance of the plane from the center and you got the same. So you equated them and you confirmed that the plane is touching the sphere. Here in the question, he gave you that the plane touches the sphere. Because the plane touches the sphere, you can equate the distance of the plane from the center to the radius of the sphere. Okay, this is the distance of the plane from the center of the sphere you got just now like this, and radius of the sphere you got this much. You equate both, girls. When you equate both, what will you get? You square on both sides to avoid modulus. You square on both sides and simplify. When you square this, you will get minus 3 lambda by 2 plus 9 whole square by 5 square, and right side square root and square will be cancelled, and that 5 square if you bring to right side, it would be 25 into this much. So 5 square means 25. When you simplify and like here factorize, you get lambda plus 4 into 4 lambda plus 11 is equal to 0. From this, lambda is equal to minus 4. From this, you get lambda is equal to minus 11 by 4. So you substitute these values in the given required sphere, girls. You are going to find out a sphere. What sphere? Sphere passing through the circle. So that we denote by S dash. In this you substitute lambda value. So when you substitute lambda value, now here lambda has two different values. So when you substitute for lambda minus 4, you get this equation. And also when you put for lambda minus 11 by 4, you get this equation. If you want, you can simplify this. 4 into x square plus y square plus z square minus 6x minus 11y minus 22, minus plus 22 is that you can do that way. Okay. If you want, you can put one more bracket here so that it will be easy for you to understand. So, no. This is correct. Only lambda y. No, it is, yeah, it is only lambda y. Correct. So now that's why in the question he gave you sometimes no equations, but you have to read it as equation only. For two different values of lambda, you will get two different spheres. So what did we do? First, you found out one problem is there. That is what to check whether the given plane touches the sphere. To check means you find out the radius of the sphere, you find out the distance of the plane from the center of the sphere, you see whether they are equal. Okay, here the radius of the sphere is 3 and distance of the plane from the center of the sphere is 3. So because they are equal, you confirm that the plane is touching the sphere. And also he asked you to find out the point of contact. And this P, point of contact, if you see the figure, this is a point on the line CP and a point on the plane pi. So first you find out the point on the line CP. So for which you have to find out the equation of the line CP. Equation of the line CP means you know the point C and you know the drs of CP. So you find out the equation of the line CP and then afterwards you took the point P, any point on the line CP. And this being a point on the line CP and also a point on the plane pi, it will satisfy the equation of the plane pi from which you got the value T. And on substituting T in P, you got the point of contact. The first question is very clearly asked you to check whether the plane touches the sphere. Whereas second question, he gave you that a plane is touching the sphere. In that case, what is the equation of the sphere? Okay. So first of all, you have to find out the sphere passing through the circle. I found out the equation of the sphere passing through the circle. And now this sphere is intersecting this plane. So you have to equate the radius of this sphere to the distance of this plane from the center of the sphere because they are touching. So that's why I found out the radius of the sphere and also I found out the distance of the plane from the center of the sphere and I equated them because S dash touches the plane pi dash. After equating those two, you simplify and get the lambda values. After getting the lambda values, substitute in the required sphere, which is the sphere passing through the given circle and touching the given plane. Okay. So what condition you have to remember is when a plane is touching a sphere, remember the distance of the plane from the center of the sphere is exactly equal to the radius of the sphere. Okay, girls. Is that clear to you, girls? Any doubt? Anyway, today the class is over.